Hey everyone, welcome to the exciting world of 7th grade math. Are you ready to unlock the secrets of numbers? Math is like a superpower. It helps us understand the world around us and solve all sorts of problems. In this crash course, we'll explore key concepts like integers, fractions, ratios, equations, geometry, and more. Don't worry, we'll keep it fun and easy to understand. Get ready to be amazed by how much you can learn. Together, we'll conquer any math challenge that comes our way. Let's dive in and discover the magic of math. Imagine a line that goes on forever in both directions. This line is not just any line, it's a special one that helps us understand numbers better. This is the number line. It's a powerful tool in mathematics that helps us visualize and understand the relationship between numbers. It's home to all positive and negative numbers, including zero. Zero is the central point, the dividing line between positive and negative numbers. Positive numbers are greater than zero. They live on the right side of the zero on the number line. These numbers represent quantities that we often encounter in everyday life. Think of things like having 5 cookies or a temperature of 10 degrees Celsius. Positive numbers can represent anything from the number of items you have to the temperature on a warm day. Negative numbers are less than zero. They live on the left side of the zero. These numbers might seem a bit tricky at first, but they are just as important as positive numbers. Think of owing someone $3 or a temperature of -5 degrees Celsius. Negative numbers can represent debt or temperatures below freezing. The further a number is to the right on the number line, the greater it is. This means that as you move right, the numbers increase in value. For example, 5 is greater than -2. This is because 5 is further to the right on the number line compared to -2. Understanding integers is key to many math concepts, so let's practice. By practicing, you can become more comfortable with positive and negative numbers. Can you tell me which number is greater, -10 or -5? Remember, the number closer to 0 is greater, so -5 is greater than -10. Great job! Keep practicing and soon you'll master the number line and all the numbers it holds. Imagine you're piloting a hot air balloon. Adding a positive number is like releasing hot air. You go up. Adding a negative number is like adding weight. You go down. Subtracting a positive number is like adding weight. You go down. And subtracting a negative number is like releasing hot air. You go up. For example, 5 plus 3 equals 8. You go up 3 units from 5 on the number line. And 2 minus -4 is like 2 plus 4 equals 6. You go up 4 units from 2 on the number line. Let's practice. What's the answer to -3 plus 5? As secret agents, we use codes to send secret messages. Multiplying and dividing integers is like cracking a code. Here's the key. When multiplying or dividing 2 positive numbers, the answer is positive. When multiplying or dividing 2 negative numbers, the answer is also positive. When multiplying or dividing 1 positive and 1 negative number, the answer is negative. For example, 3 times 4 equals 12. Both positive, answer is positive. And -2 times -5 equals 10. Both negative, answer is positive. But 6 divided by -2 equals -3. 1 positive, 1 negative, answer is negative. Ready to crack the code? What's the answer to -10 divided by -2? Section 5. Fractions and decimals, slicing up pizza and sharing candy. In this section, we will explore how fractions and decimals help us understand parts of a whole in a fun and relatable way. Fractions and decimals represent parts of a whole. They are essential in everyday life, from cooking recipes to dividing up chores. Think of slicing a pizza into equal slices or dividing a bag of candy among friends. These activities are perfect examples of how we use fractions and decimals without even realizing it. The bottom number of a fraction, the denominator, tells you how many total parts there are. It's like the total number of slices in a pizza. The top number, the numerator, tells you how many parts you have. So if you have 3 slices out of 8, your fraction is 3/8. For example, 3/4 of a pizza means the pizza is cut into 4 slices, and you have 3 of them. This is a practical way to see fractions in action. Decimals use a decimal point to separate the whole number from the fractional part. They are another way to represent parts of a whole. For example, 0.75 represents 75 hundredths, which is the same as 3/4. This shows how fractions and decimals are interconnected. We can convert between fractions and decimals easily. Understanding this conversion helps in various real-life situations, like measuring ingredients or calculating discounts. For example, 1/2 is the same as 0.5, and 1/4 is the same as 0.25. These conversions are fundamental in math and everyday tasks. Can you tell me what fraction of the pizza is left if you eat 2 slices out of 8? This is a great way to practice your understanding of fractions. If you start with 8 slices and eat 2, you have 6 slices left, which is 6/8 or 3/4 of the pizza. Understanding these concepts makes math more enjoyable and practical. Section 6. Ratios and proportions. Recipes for success. In this section, we will explore how understanding ratios and proportions can help us in both math and everyday life. Ratios and proportions help us compare quantities and solve problems involving scaling. They are fundamental concepts that can be applied in various scenarios, from cooking to construction. Think of a recipe. The ratio of ingredients determines the taste and the final product. For instance, the right balance of sugar and flour can make or break a cake. A ratio compares two quantities. It tells us how much of one thing there is compared to another. This comparison is crucial in many fields, including science, engineering, and finance. For example, if a recipe calls for 2 cups of flour and 1 cup of sugar, the ratio of flour to sugar is 2 to 1. This means for every 2 parts of flour, there is 1 part of sugar. Proportions are equations that state that 2 ratios are equal. They help us understand how different quantities relate to each other and ensure consistency in recipes and other applications. For example, if we want to double the recipe above, we would use 4 cups of flour and 2 cups of sugar, maintaining the 2 to 1 ratio. This ensures that the taste and texture of the final product remain consistent. Let's try a recipe challenge. Understanding ratios and proportions can make cooking more fun and less stressful. It also helps in scaling recipes up or down based on the number of servings needed. If we need 3 eggs for every 2 cups of flour, how many eggs do we need for 6 cups of flour? By setting up a proportion, we can solve this easily. The answer is 9 eggs, maintaining the same ratio. Congratulations! You've just used ratios and proportions to solve a real-world problem. Keep practicing, and soon you'll be a master at using these concepts in various situations. Section 7. Expressions and equations. Solving mysteries with algebra. Expressions and equations are like solving mysteries with math. An expression is a combination of numbers, variables, and operations. For example, 2x plus 3 is an expression. An equation is a statement that 2 expressions are equal. Equations often involve solving for an unknown variable. For example, if we have the equation 2x plus 3 equals 9, we can solve for x by subtracting 3 from both sides and then dividing by 2, giving us x equals 3. Ready to be a math detective? Can you solve for x in the equation x minus 5 equals 10? Section 8. Geometry basics, shapes, angles, and real-world applications. Geometry is all about shapes, sizes, and their properties. We encounter geometry every day, from the buildings we see to the objects we use. We learn about different types of triangles, quadrilaterals, circles, and more. We also explore concepts like perimeter, which is the distance around a shape, and area, which is the space inside a shape. Angles are formed when 2 rays meet at a point. We learn about acute angles, which are less than 90 degrees, right angles exactly 90 degrees, obtuse angles greater than 90 degrees, and straight angles, which are 180 degrees. Can you spot a right angle in your classroom? How about an acute angle? Section 9. Data analysis and probability. Making sense of information. Data analysis and probability help us make sense of information and predict outcomes. Data can be collected, organized, and displayed in various ways, such as tables, charts, and graphs. Probability is the likelihood of an event occurring. It's expressed as a fraction or percentage. For example, if you flip a coin, the probability of getting heads is 1/2 or 50%. Understanding data and probability helps us make informed decisions in various aspects of life, from analyzing trends to making predictions about the future. Can you think of any examples where understanding data and probability would be helpful in real life? Section 10. Let's review your math muscles are growing. Congratulations, math champions. We've covered a lot of ground today, from integers and fractions to geometry and data analysis. Remember, practice makes perfect. Keep exploring these concepts with the help of your textbooks, teachers, and online resources. The more you practice, the stronger your math muscles will become. Don't be afraid to ask questions and seek help when you need it. Math can be challenging at times, but with dedication and perseverance, you can achieve anything you set your mind to. You've got this. Section 11. Fun fact. Math is everywhere. Did you know that math is found everywhere in nature? From the spiral patterns of seashells to the symmetrical designs of snowflakes, math is all around us. The Fibonacci sequence, where each number is the sum of the 2 preceding ones, like 1, 1, 2, 3, 5, 8, appears frequently in nature, governing the arrangement of petals in flowers, the branching of trees, and even the proportions of the human body. Math is a universal language that helps us understand the beauty and complexity of the world around us. So keep exploring, keep learning, and never stop being curious about the wonders of math. Keep those math brains buzzing.